All right. Thank you for joining us today for the RGEM speaker series. I am Lindsey Beacham with the University of Idaho Water Resources Research Institute, or IWRRI, in Coeur d'Alene. The RGEM Coeur d'Alene Lake Collaborative is a team of professionals working to preserve the lake health and protect water quality by promoting community awareness of local issues through education, outreach, and stewardship. We have representatives from the University of Idaho Water Resources Research Institute, the Coeur d'Alene Tribe, Idaho Department of Environmental Quality, Kootenai County, Kootenai Environmental Alliance, the Basin Environmental Improvement Project Commission, and the Coeur d'Alene Regional Chamber. You can learn more about the collaborative at uidaho.edu/rgem. Our speaker today is Dr. Meg Wolf. Meg holds a PhD in hydrology from the University of Utah and serves as the Assistant Director of IWRRI, based out of the Coeur d'Alene Harbor Center. She is dedicated to expanding water-related research opportunities in North Idaho and fostering collaboration between local stakeholders and university researchers across the state. Ask questions at any time, but we will save them for the end. Thank you. And Meg, if you would like to take it from here.
Awesome. Thank you, everybody, for joining today. This is our first revamp of the RGEM speaker series, and I'm excited to kick it off. So as Lindsey mentioned, my name is Meg Wolf. I work up here at the Coeur d'Alene Harbor Center with the University of Idaho. I'm the assistant director for the Idaho Water Resources Research Institute, which is also known as IWRRI. I have a background in hydrology. I received my PhD from the University of Utah recently, and I'm excited to tell you all a little bit more about the work that we've been doing up here in North Idaho related to Lake Coeur d'Alene, and give you a little bit of an update on the Baywatchers program. Hold on. Okay, so the Baywatchers are lake education ambassadors. And the program is run as a part of the broader IWRRI outreach that we are working on across the state and specifically here in North Idaho. And Baywatchers is in partnership with the RGEM Collaborative as well. So I'm going to be giving you a little bit of a 2024 water quality sampling update, so what we did in the previous season, and then also put it into context of a broader overview of the lake, and what I've learned so far. I grew up in North Idaho, and I had a sense of all of the amazing natural resources that we have here related to Lake Coeur d'Alene and recreation and the forests that surround them. So I want to try to give a little bit of a context of how we're monitoring the lake, in addition to the other entities that also monitor and manage water quality specific to Lake Coeur d'Alene. So we are specifically monitoring the bays of Lake Coeur d'Alene. Lake Coeur d'Alene is a very uniquely shaped lake that has a lot of intricacies. And a lot of the monitoring that's happened in the past has been in the central part of the lake, in the larger and deeper areas of the lake. But it was identified pretty early on that if we can monitor these smaller bays and these smaller local areas, we can have a little bit better sense of what's how the lake might be changing, especially in the shallower parts of the lake. So the goals for monitoring in the association with Baywatchers was to detect early signs of nutrient enrichment, algal growth, or abnormal water quality, identify trends in lake water quality over time. And then the benefit here also is that these volunteers are all very connected to the lake in a lot of different ways, whether that's through recreation and property ownership. But it also gives an opportunity for our neighbors on the lake to have a better idea of what's going on within each of their own individual bays, but then also in the scope of the broader lake. So our 2024 Baywatcher season highlights, we sample for water quality in June, July, August, and September in 11 bays. We provide a comprehensive data report following that September sampling. So that's what I've been working on now, and you'll get to see a little bit of that. And then we also are working on data management sharing with both Coeur d'Alene Tribe and Idaho DEQ. So this bay monitoring, Bay Watchers data can actually be used in a broader sense of understanding the whole lake as a system. So I would first want to start off by thanking our 2024 Bay Watchers. We monitor from north to south. Spokane River, we have Susan and Bob Steiger, David Wold, Bruce Sear, Jim Duff, Barb and Bob McFarland, Joe and Lynn Morris, Julie Fromm, Steve Wilson, and Chris Kellogg. And then an extra special thanks to Mike Woody, who is our education and outreach coordinator for IWRRI. And Woody is our boat captain and water quality collector extraordinaire. And we also had a summer intern this summer, Alex Kienow, and he worked a lot and went out on a lot of the samplings with our Bay Watchers, and he put together a summer undergraduate research project. So some of the data that I'm going to show you today is also figures from Alex's poster that he presented at the end of last summer. So what we actually do for monitoring, so we monitor, as I mentioned, at 11 sites around Lake Coeur d'Alene with the support of our fantastic Bay Watchers. We have a boat here at the Coeur d'Alene Harbor Center that we use for this water quality sampling, which we take out to get to each of these sites. Some of the sites, we have long-term temperature monitoring using a hobo sensor. So this is a stationary sensor that stays off the dock and takes measurements at 15-minute intervals throughout the entire summer season. And then we also go out monthly and measure a profile of water quality from the surface to the bottom of the lake. And those measurements include dissolved oxygen, temperature, pH, and then we also do a Secchi measurement with and without a view tube. And I'll go into a little bit more detail on each of those and why those matter and why we monitor for them. So in the context of the broader system, why do we monitor water quality in Lake Coeur d'Alene? So we started this monitoring program in 2019, which is relatively recently. So we have Bay monitoring data for approximately 5 years. But long-term monitoring is really essential, especially in the face of change. So this figure on the left is from the Coeur d'Alene Climate Adaptation Project report that was released in May of 2024 by the Kootenai Environmental Alliance. And a couple of the key impacts that Lake Coeur d'Alene faces in light of climate change is one, air temperature, which is going to impact a significant amount of things, but the first one being the transition from snow to rain, potentially impacting the timing of spring runoff. So when and how much water comes out of both the St. Joe and the Coeur d'Alene River systems. It's also likely to impact lake water temperature itself. So the warmer the air temperature, the higher availability for water temperature increases as well. And then also thinking about the lake water quality response and to headwater change, such as increased risk of wildfires and how that might impact lake water quality in the future. And unique to Lake Coeur d'Alene, as many of you know, is a history of legacy mine waste that has severely impacted the sediments and the sediment loading that have come into Lake Coeur d'Alene. This is a photo from the headwaters of the Coeur d'Alene River, and essentially with over a century of mining and mine tailings being flushed slowly or rapidly during flood events into the Coeur d'Alene River system and then into the lake has significantly impacted the sediment types and what contamination is included in the sediments of Lake Coeur d'Alene, giving Lake Coeur d'Alene a unique water quality situation, which should be monitored over time to see its response to change. Additionally, the sediment loading that's happening coming out of the Coeur d'Alene River is still significant and still happening, despite the fact that mining was primarily, or the primary amount of mine waste that was produced is from the early 1900s. There is still mining happening in the headwaters, and so monitoring and those sediments are still being flushed out. So the floodplain in the middle basin of the Lake Coeur d'Alene, so this is the red outline here. I think you can see my mouse, but maybe you can't. Is a map of how lead has impacted the sediments within the floodplain of the Coeur d'Alene River Basin, and then also in Lake Coeur d'Alene itself. And what you'll notice is that there's a pretty significant gradient from south to north, where the south end of the lake has a different impact level of mining contamination than the north end of the lake, primarily due to the flow of water coming from the St. Joe headwaters at the south end of the lake, not impacted by legacy mine waste, whereas the central part of the lake, where the Coeur d'Alene River flows in near Harrison, is impacted by legacy mine waste. As I mentioned, the water quality in the central, or in the part of the lake that is used by recreationists and that actually flows out into the Spokane River, has relatively low contamination when observed within the water column. Whereas most of the sedimentation, or most of the contamination of lead, arsenic, zinc, cadmium, and copper is dispersed within the sediments. And so this is just a figure of indicating the relatively low concentrations in micrograms per liter of lead in the water column as reported in the 2021 NAS report, National Academy of Science report. But what we want to make sure is that those sediments that have heavy metal concentrations, that those metals stay within the sediments and that they're not released back into the water column. We also want to think about how the lake might respond to how human activities are ongoing in the headwaters. As many of you know, development and land use change has been relatively significant in the North Idaho Panhandle, including population growth as well as forestry activities. So this little video is a time lapse from Google Earth Engine from 1984 until 2029 or 2024. And if it plays, what you'll notice, you'll start to see, if we look down in the bottom right, that's the headwaters of the St. Joe and the headwaters of the Coeur d'Alene. What you'll see is that there's a slight change, or there's an incremental change of forestry activity, right? So logging is a major part of Idaho's economy. And from 1984 to 2024, in the last 40 years, we have harvested a lot of these forests in the headwaters. So monitoring what's happening downstream is really important to put into context how these changes in the headwaters might also be impacting the water quality in the lower part of the watershed, which is Lake Coeur d'Alene. And one of the challenges associated with deforestation or a change in headwater structure is the release of nutrients into the system from essentially runoff. So from runoff processes that are happening in the higher elevation areas of the watershed, which are releasing or every year cycling nutrients in a different way. And what we can think about how nutrients affect lakes is through this process called eutrophication. So eutrophication from an ecological standpoint is a result of excess nutrients within a system. A lot of times those nutrients we think of are phosphorus and nitrogen, and they can enter lakes from varying runoff sources. They can be from point sources such as wastewater, or non-point sources like land use change in headwaters. What happens when we have an abundance of nutrients is that algae production increases when nutrients are available. Those algae are prolific for a certain amount of time, often creating an algae bloom. And then those algae decompose or die. They fall to the bottom of the lake or the water body, and they start to decompose. And that decomposition process essentially takes up oxygen. So that can lead to anoxic conditions, which is a low oxygen condition. And the concern with a low oxygen condition is that metals and other nutrients, including phosphorus and ammonia that are bound to the sediments in the bottom of the lake, in low oxygen situations, can be re-released back into the water column where they were previously bound by an oxygen layer. So that is a concern associated with eutrophication process, is the low oxygen levels within the lake and the re-release of both nutrients and metals, the potential for that to happen from the sediments back into the water column. So in the context of what we have been doing for our Baywatchers monitoring is trying to think about the lake as a stratified system where we have the upper layer of warm, less dense oxygenated water that's often teeming with life, even if we don't see it. That's called the epilimnium. There's the metalimnium, which is essentially the transition zone between the upper water column and the lower water column. And then the hypolimnium, which is colder, denser water. And that stratification happens mostly during the summertime, where we can get a pretty strong thermocline, which is the transition between cool to warm that you notice in that middle figure. And this fluxes throughout the season. So that thermocline or that thermal stratification is the strongest during the middle of the summer. As you might imagine, if you guys have ever jumped in Lake Alene, the upper meter or 2 meters of water is relatively warm. It feels great. Maybe if you dive down a little bit deeper, your toes get down there, it's significantly colder. So that means that you're reaching the metalimnium, or if you were to dive really deep, that would be significantly colder than the surface water. And that changes throughout the year with a fall cycling and a spring cycling. And winter, the entire lake is typically the same temperature throughout the entire water column. This is what we monitor for in our depth profiles that we take. And then we also monitor for dissolved oxygen. As we mentioned, dissolved oxygen drives biology and chemistry of lakes. And low oxygen environments are both detrimental on the biological side, where trout and other fish species have a required dissolved oxygen limit for success. So trout have a 6 milligrams per liter dissolved oxygen level, and bass and carp, they can survive greater than 3. So essentially they are more resilient in lower oxygen levels, but they don't mind it if there's higher oxygen levels. And then there's also this positive feedback loop that I've discussed briefly, where if we have excess nutrients leads to higher algae growth, more decomposition, which leads to decreased dissolved oxygen, and then a cycle of release of other nutrients that have previously been bound in sediments. So preventing this extra release of nutrients is also important for lake management and thinking about algae growth and algae blooms throughout the entire Lake Coeur d'Alene system. We also monitor for essentially water clarity. So Secchi monitoring measures the water column transparency to light. and indicates how deep in the water column plants can photosynthesize, essentially breaking up rather than by temperature, but by the photic zone and the aphotic zone of where plants can thrive. Secchi monitoring is also an indicator of trophic boundaries, which kind of goes back to that eutrophic state, right? Where eutrophication means really high nutrient levels, high amounts of algae growth. So this is the right side of our green spectrum. And that also is associated with low Secchi depth. So that means if you were to look into a pond versus a nice clear oligotrophic lake, the eutrophic pond would have relatively low Secchi depth measurements. So that top 1 to 2 meters, you wouldn't be able to see the disk anymore. Where in a nice cool mountain lake, such as Lake Coeur d'Alene, that Secchi depth, you can see pretty far down, as we are very lucky having extremely clear lakes up here in North Idaho. So for the 2024 data overview, first I want to put a little bit of context of what our winter was like the previous year. So we're now in the 2025 water year. We were in the 2024 water year. 2024 mountain snowpack, as many of you know, was relatively below average. We had a relatively rainy year, but the snow water equivalent in the spring of 2024 was at approximately 69% for the Spokane River Basin, which is where Lake Coeur d'Alene falls. And you'll notice that in the hydrograph, although Lake Coeur d'Alene is managed by the Post Falls Dam, we can see that from 2019, 2020, 2021, 2022, 23, and 24, there was not a huge significant runoff event that happened in the spring of 24, likely because we had a relatively low snow year, and that snow water equivalent was below average. Comparatively to a year such as 2011, where there was a relatively big snow year and really high runoff events. We can, so digging into a little bit of our data, we have these HOBO sensors, which are temperature incremental monitoring at 15-minute intervals throughout the entire season. And we start those in the middle of June until we pull them at the end of September or early October. And what you'll see is that seasonal temperature variation from north to south across the lake is not super significant, where the north end of the lake and the south end of the lake have actually really similar temperature variations within each of these very different bays. We have Rockford Bay, Cave Bay, Leaning Pine Point, and Cottonwood Bay. And these, but what you do notice is there's a relatively steep trend into July and August, and then a slower tail falling into September and October when temperatures get relatively cool. One thing to note, we had a relatively warm September, so temperatures extended and stayed above average throughout the September months, and then started to dip off once we reached October. This thermocline is associated with that summertime cycling. So we can think about the surface temperature over time in the sense of our spring to summer to fall temperature changes. We can also think about them as a depth within our the depth of the lake, where the surface of the lake is going to have relatively warm temperatures, and the bottom of the lake down 20 meters here at Beauty Bay is significantly cooler. So what you'll see is the temperature in June is relatively cool still. So that's likely a function of both air temperature, where June has not had a significant amount of time for the upper parts of the lake to warm up. But also there's an influx of water still flushing in from the Coeur d'Alene River and the St. Joe River, creating kind of a constant stream of new, cool, fresh water that's coming in the spring. As the lake warms up, the runoff reduces, it becomes more stratified. So the upper layers of the water in July and August, that brown and the red dots have a lot higher surface temperature. But what's really important and significant for Lake Coeur d'Alene is that those lower levels, those deeper levels, there's relatively no difference between the June and the September temperatures, which is the blue line in this figure. So just you can see that significant thermocline from the cooler, deeper, denser waters to the warmer waters. And what we've been doing is monitoring these for every year. So going from 2019 to 2024, I recognize that these are relatively busy figures. This is a lot of data here at Leaning Pine Point. But what you'll notice is there's no significant outliers, but there are some temperatures approaching above 25 degrees centigrade, which is relatively warm for Lake Coeur d'Alene. That the water year in August of 2022, many of you remember that summer was extremely hot, extremely smoky. The July 2021 water year temperature exceeded all of the other July temperatures, partly because of the heat dome that was associated with our 2021 heat dome. So what's interesting is that we can think about abnormalities within the system, but what we do like to see is that thermocline present over the multiple years of monitoring, which we do observe. The other thing we look at is dissolved oxygen. And dissolved oxygen, as we mentioned, the ideal zone for trout is 6 milligrams per liter and above. Here I have it as essentially the green zone is 7 and above, which most of our dissolved oxygen throughout the entire water column is, with a couple data points dipping below that in a couple situations. So here we monitor for abnormalities, and essentially what we would do is think about this system over time as it's changing, and then also if there's any outlier data, we can assess if that outlier is reasonable, or if it should go back and be double checked for a cause for concern for low dissolved oxygen levels within that bay. pH is another thing that we monitor, essentially looking for outliers again as well. For the healthy range of aquatic life for pH is between 6.5 to 8.5. And anything below that is relatively challenging for aquatic life. And so as you can see, the majority of our samples are within that healthy range for an oligotrophic lake, which Lake Coeur d'Alene is, with a couple outliers, especially in this last September, where the lake was extremely stratified for a large amount of time, potentially impacting those lower levels of pH. As I mentioned, September was abnormally warm, and that stratification held on for longer for this 2024 water year compared to previous years, where September we typically get a couple rain events, a couple big storm events where the lake starts to recirculate. We also monitor Secchi. These Secchi depths you can see range from primarily in the 6 to 9 range. And there's a couple dips there. In that 2022 water year, you can see there's a dip down to 2 to 3 meters. And we can't tell the difference whether it was sediment that was clouding the water or algae. But my hypothesis is that during that 2022 water flushing, that was a relatively big runoff year. And because those low Secchi depths were in the June water sampling period, that is because of sediment and not because of algae growth. What we're concerned, or what we want to monitor for, especially related to algae, are in the July and August and September months, if we start to see a rapid decline in Secchi depth in that upper layer of the lake, indicating an algae bloom. We do see a little bit of a trend in Secchi Disk depth from the south end of the lake, where we start to the north end of the lake. Carey Bay, Harlow Point, Cottonwood Bay, and Cave Bay on the southern end of the lake do have a little bit lower Secchi depths, so a little lower water clarity than the north end of the lake. And that could be due to a couple different reasons related to both the St. Joe headwaters differences to the Coeur d'Alene headwater and the overall depth of the lake. The south end of the lake is relatively more shallow compared to the north end of the lake. Dissolved oxygen did dip below that 7 micrograms per liter threshold in the September water year, or in the September sampling of this year in the south end of the lake. But it's not at 0. It's not a significant cause for concern, but we do want to take this data and pass it on and think about these systems, especially as we move forward into the future. So kind of going back to that Secchi data, we can think about Secchi as a function of clarity, and it can also be representative of total nutrient availability within each of these bays. As we see, June has lower Secchi depth, probably because of increased mixing and sediment. July and August are relatively clear. And what you should notice on each of these for June, July, August, September, that this line is below our mesotrophic or well into the oligotrophic range for our trophic state boundary, indicating relatively healthy water quality, especially in the sense of nutrient loading and algae growth potential for the lake. So this is the south end of the lake. The central part of the lake has a little bit even more visibility. And the very north end of the lake is relatively similar, even in the far reaches of Blue Creek Bay, which sometimes have, which are much more shallow than Rockford Bay, for example. There is still really good indicators of both trophic state nutrient loading with those Secchi depth measurements. So this is just a little bit of an overview of each individual site. The Spokane River we monitor, and we should note that that site has a much lower depth than the rest of the lake, and it's a really important monitoring location, especially as lake from the central part of the lake is moving into a river system. How is that river system differing from the rest of the lake relative to temperature, dissolved oxygen, and pH? And the 2024 water year didn't have any significant outliers in the Spokane River, which is great. We monitor off Steamboat Point, which is one of our deepest sites. And you can see that relatively significant temperature profile with the thermocline occurring really significantly. That dissolved oxygen is all within that relatively positive range. And one thing that you can see, we did an October sampling in 2021, and that's where that thermocline starts to degrade. So as the fall hits into October and December, October, November, the lake starts to overturn, and that thermal stratification starts to condense, and the entire column of the lake becomes more uniform throughout time. And one thing that we're interested in is the timing of that thermal stratification and the availability for growth to happen in that upper column of water is impacted by a number of things, like I mentioned, temperature, nutrient loading and availability, but then also how much water is being flushed into the lake from runoff events, such as a big snow year or rain on snow events. And the timing of that thermal stratification is really important for the potential length of time available for algae growth to occur. The Panhandle Yacht Club had a couple low pHs measured early in September of 2020, but the rest are all within range above that 7 mark. Temperatures, you can see that really significant profile, and the dissolved oxygen is also in that positive range. Beauty Bay on the north end of the lake. This is all of the data associated with our 2019 sampling to 2024. That bay is likely the furthest reaches of the lake, and so that's really important to monitor some of those farther from the central part of the lake. And we haven't seen any significant changes in Beauty Bay. Blue Creek Bay is really similar with less, because it's a little bit shallower, there's less of a significant thermocline associated with the Blue Creek Bay samples, where it's relatively stratified in the all the way down to that 10-meter mark. That's likely due to just where the bay is located and its function within the rest of the lake, and that it's not nearly as deep as the rest of the lake. So that entire upper column is significantly warmer than the deeper sites that we have on the lake. Leaning Pine Point, we can see that really nice thermal stratification and changes in that dissolved oxygen profile at that thermocline boundary within the lake system. Rockford Bay, again, we can see that pretty good stratification. It's not quite as deep of a site, but there is that really significant thermocline observed. Cottonwood Bay as well, with a couple outliers in our pH data from our July, which could be data errors or because of actually a significant change in pH there. Harlow Point, again, is a little bit shallower than some of our other sites, so a little bit less of a significant thermocline. But we do see that in August and in both our 2021 and 2022 water years. So the 2025 outlook, water year for this year is approximately 70% of average. I pulled this from a while ago. So I think we've had a significant bump in precipitation during our December and January snow years. It's been a couple of weeks of low pressure or high pressure systems, low snow water equivalent the last couple of weeks, but it's expected to turn around with a pretty big bump in precipitation happening in early February. So we'll see what this snow year looks like and how that will impact our 2025 water year. I am going to wrap it up there. I can open up the floor to questions if you have specific questions related to the broader scope of Lake Coeur d'Alene water quality monitoring, or individual site-specific questions, or maybe just questions in general. We'll see how this goes. Hi, Dave. Do you have a
Hi.
question?
Yeah, just curious. Love the information, love the slides. Is by chance a PDF of this presentation going to be made available?
Yes, we can make that available.
Excellent. Thank you.
Okay. Next, Robert Schobert.
Go ahead, Rod. Rod, oh, there you go.
Okay, can you hear me now? Okay,
Yes.
good. Okay, just wondering on, do you have any way of characterizing modern day mining and the impact on the environment versus say 100 to 130, 20 years ago?
That's a great question. I think that there's been a couple initiatives, especially with modern day mining um, tailings management. So the protocols associated with modern day tailing pile management is not to just dump it straight into the river, which is a good thing. I know that some practices include taking tailings and reprocessing them so that they're extra removed of the metals associated with, especially the financial interest, but then also for the lower level metals that are less financially lucrative. And then also taking those tailings and putting them back into older mines. So that is a process for mine tailing management that reduces the potential for runoff exposure. So exposure to rain events, flood events, especially within the floodplain. And then whether it's being transferred back into a mine shaft or outside of the floodplain. So mine tailing management is especially important to think about the floodplain system, and where it used to be thought of as like just as long as it wasn't really close to the river, it wasn't in the floodplain. But management of mapping floodplains is really important for mine tailing management. I'm also pretty new to understanding mining as a system. So I'm sure there's other people that might have a little bit better ways to address that specific question. But thanks, Rod.
Thank you.
I had one question in the chat from Lita Kobazar. She said, thank you. And I'm wondering what monitoring protocols, if they will remain consistent into the future, or if there's more things we would like to monitor and why. Great question, Lita. A couple of the things we notice is our monthly sampling is helpful, but our kind of incremental monitoring of that temperature profiles over time gives us a little bit better sense of how changes might be happening at a finer scale or time instrument. So potentially installing temperature monitoring at more docks, at more incremental profiles. A couple of the docks we have them at a 3 meter and a 10 meter. So we're trying to capture the surface and that deeper level. But if we could have a longer time series at a higher frequency of sampling, as you can imagine, going out and taking samples is more time intensive than having a data recorder within the water column. So that might be an opportunity for increasing our time series availability and monitoring of change, especially if there's kind of like a storm event or a rain event. We can kind of capture the incremental change where we're not actually out on the boat during that time.
Hey there,
Thanks,
can
Ken.
you hear me
Kendra.
okay, Meg?
Yeah.
Okay. Nice presentation. I was curious about one of the slides back when you showed where the thermocline started flipping. And I was wondering if that data point, that time of year, is something that will continue to be monitored in the future, or like kind of what are your thoughts on including that kind of data?
Yeah. So that I think you're associating with like the October data points. So
Yeah.
most of the years we've primarily gone out during the summer sampling season. Partly that's when the boat is in and when people are excited to be out on the boat. October is a little bit more challenging for logistics, but I think it would be great to include an earlier sample so we can get a better sense of the spring temperature climb before that June sampling, so maybe a May event, and then also a little bit more frequency in this October. And like I said, also having those temperature profile monitorings at multiple different depths could give us a better sense of the longevity or when that thermocline starts to switch. Whether that's maybe we caught it on October 6th and maybe it just started to happen, or maybe it happened in September of that year, but we just didn't sample between that time period.
Yeah, awesome. Thank you.
Lita also mentioned thinking about kind of episodic events related to smoke deposition. So the wildfire season last year was actually relatively smoke-free compared to other seasons, but it might be interesting to think about water quality in the sense of following large wildfire events, such as the 2023 year was relatively smoky, how that impacts lake temperature or other water quality constituents. So thanks, Lita. Any other questions? Okay. Well, we're a little bit early on our time, but it's almost 12:50. I want to thank you all for coming. Thank you all for your questions. If you have any questions, my email is mawolf@uidaho.edu. And we will try to, I think that I can try to get a slide deck of these slides posted, and I can get it out to this email group that you are all part of. So again, thank you so much, and I hope you all join us for our next RGEM speaker series. Lindsay, do you have anything else to add?
You covered it. Next month, it'll be Lauren Zinther, and she will present on how water quality trends guide remediation. So thank you everyone for joining us.